next part of this lecture is we'll talk about like different practical considerations, like regarding the shape of those volumes. So when we are moving from volume to volume inside a neural network, how that shape is actually controlled and what we can do about if we want like any specific shape. Okay, so let's try to go over like again this convolution operation. For example, if we have a 7x7 map, and again this is like some patch from your image, or this could be your input image, or it could be like any activation map, like intermediate activation map inside your neural network. In this case, it's 7x7, it could be anything. And let's say we have a filter 3x3. Now, what will happen is when we are trying to convolve, the idea is to place this filter at all the possible locations in this feature map. And as you can see, like this is the first possible location if you start from like left and top. So you are placing at this location. You can't place at this location because we don't have any values in the neighborhood. Okay, so that will be the first location. So you will get one value for this location. This could be the second one, and you can keep going towards the right. So you can see that as you stride like from left to right, you are able to place at 5 different locations, starting from this one, 1, 2, 3, 4, and 5. So if you're able to place at 5 locations, which means you are going to get 5 different activation values as you move from left to right. And the same thing will happen if you move from top to bottom. So that will result in an output activation map, which will have resolution 5x5. Okay, so which means that if you have an activation map of 7x7 using a 3x3 filter, your resolution will reduce from 7x7 to 5x5. Okay, so you can actually create a very simple formula to find this out, so you don't have to worry about like how the shape will change. And it's pretty straightforward formula. N is like your, and again, this is for one dimension. You can apply like the same formula for multiple dimensions, and you can achieve the values. Okay, so N is the length of your feature map. So in this case, in X direction, it's 7. And F is the size of the filter. In this case, it's 3. You just add that to 1. So that's input size, filter size, and usually like our feature maps are like kind of even shape, right? So it will 7x7, 8x8 or something like that. And your filters are also like symmetric. You don't use like odd shaped filters. So then you can put like these values in this equation, and that's going to give you 5. You can replace with whatever values you have, depending upon your size of activation map and your filter. You can get like what's going to be the shape of the output activation map.